All right, so we've got congruent figures. I'm going to see, I don't know, I think that's a little better. It doesn't reflect as much. So congruent figures. Congruent figures, to be congruent, that means they have the same size and the same shape. So if you think about the last unit, tying things into the last unit, when we talk about congruent figures, that means that they can be a reflection of themselves, so that it's just a picture flipped. It can be a rotation of itself. And our last one was a slide, which is a translation. So if we look at the bottom right here, we want to say, are they congruent, yes or no? So congruent, again, means the same size or shape. So look at these dollar bills. Do we care that this is $1 and that's $10, other than the fact for our bank account or our wallet? No. Look at the size and the shape. They are the same size and the shape, so we're going to say, yes, they are congruent. If you look at these little wooden corners, they're like wooden corners of a picture frame. Are they the same size and shape? No, they're not. This one's thicker than this one. So take a minute, pause your video, do the others. How'd you do? All right, so if we open to the next page, now we're talking specifically about triangles. So if we talk specifically about triangles, congruent triangles are still going to have the same size and the same shape. Their corresponding parts, so corresponding means the same place but in the other figure. So like the left angle and the left angle, the right angle and the right angle. So corresponding parts, both the angles and the sides, are going to be congruent. And that means we can make a congruency statement which means that we can say one triangle equals the other triangle. All right, so if we talk about congruent angles, what that means is we have angle K. Angle K is the first angle listed in this triangle, so we're going to say it's congruent to whatever the first angle listed is in the second triangle, which is angle N. We're then going to say the second angle in this triangle, so angle A, is congruent to the second angle listed in this triangle, which is angle E. And last but not least, we have the third angle, T, is congruent to the third angle, W. All right, so then we're going to do the same thing with our sides. We're going to say that our first side is KA, so the first two letters in our triangle. So they are congruent to the first two letters in this triangle, which are NE. Then you're going to say the next two letters, so AT, are congruent to the next two letters in my other triangle, so EW. So again, AT is in the second place and the third place in this triangle, so we're comparing it to whatever's in the second and the third place in this triangle. Our last side that we haven't talked about, we've talked about KA, AT, we have not talked about KT being congruent to NW. And here's something that I forgot to point out and make you star and stuff. Order matters. Whatever is matched together is assumed to be congruent. So like whatever comes first goes with the first. Whatever comes second goes with the second. You have to remember order matters because it makes a really big difference in your congruency statement. So take a second, pause your video, and do the bottom half. Sorry. How'd you do? Did you do okay? Yay! All right, let's look at our next one. So, we're going to start talking about isosceles triangles. Isosceles triangles have two congruent sides, and they have two congruent angles. So what that means, if I have two sides of a triangle congruent, so if your picture looks like this, you can then make it look like this. That means if you have two congruent sides, their opposite angles are congruent. And vice versa. If your picture looks like this, you have two angles that are congruent. You know that their opposite sides, the sides directly across from them, are congruent. Don't know how that popped up. All right, so we've got triangle PQR. We're going to label our triangle as P, Q, and then R. We know P is congruent to Q, so we're going to mark those. And then if P is congruent to Q, then PR is congruent to QR. Then we're going to label PQ as 6x minus 12. We're going to label PR as x plus 20. And then we're going to label RQ as 8x over 3. That's a fraction. It's not written very pretty, but it is a fraction. All right, so two of these sides matter to solve for x, one does not. The two sides that matter to solve for x are these two because they're congruent, and congruent is a fancy word for equal. So we're going to set them equal to each other. And then, how do we get rid of division? You multiply. So I'm going to multiply both sides by 3. And over here, you have to make sure you multiply the entire thing. So these guys cancel out. I'm going to take 3, I'm going to multiply it times x, and then I'm going to multiply it times 20. So I have 3x plus 60 equals 8x. I need to get my x's together. These cancel, and I get 60 equals 5x. I divide both sides by 5, and I get 12 equals x. Now, notice, 12 equals x, but we want to know what are the lengths of all three sides of the triangle. So if all three sides of the triangle, we've got to take that and plug it in. So we have 6 times 12 minus 12. That's going to give us 60. We have 12 plus 20, which is going to give us 32. And then even though we know it's an isosceles triangle and these are the same, we want to go ahead and plug it in and double check because that'll make sure we got our x right. So if we do 8 times 12 divided by 3, that does in fact give us 32. All right, so go to the next page. We have triangle MEL. We have ME is congruent to LE. So that means ME and LE have to be these two sides. So I'm going to label this as ME. And then this is going to be LE. We're going to mark them congruent. And then if we know the sides are congruent, we also know their angles are congruent. So if your sides are congruent and your angles are congruent, then we know the measure of angle M is negative 4x plus 9, and we have the measure of angle L is 8x minus 3. Congruent angles you set equal to each other, so we have negative 4x plus 9 equals 8x minus 3. So take a minute, pause your video, and solve it. You should get x equals 1. If you don't know how to get x equals 1, talk to your neighbor. All right, this guy, we're going to label it as BA HA, because that's a congruent sign, and then HA, that's a congruent side. We're going to mark them congruent. If your triangles are congruent, or your sides are congruent, then your angles are congruent. We're going to label this guy as 28, this guy as 5x plus 9. This one is different because we have the top angle not, our x is in our vertex angle up here, it's not in our congruent angles.
I'm going to give this to John.
So this angle means that I have 28 degrees because they're congruent. And then so all three angles in a triangle are going to do what? Add up to 180. So pause your video and solve it. You should get x equals 23. If you don't know how to get x equals 23, ask your neighbor. All right. KED, this triangle is not facing the same way, which means our congruent angles are this one at the top and the one at the bottom. So we're going to label them K and D. We're going to label our vertex angle E, and then we're going to name our sides. So we have KE. Oh, first off, if we know angles are congruent, then their opposite sides are also congruent. We've got KE is 8x minus 1. KD is 2x plus 11. And then ED is 4x plus 5. So the two sides we care about are these two guys right here because they're our congruent sides. So we're going to say 4x plus 5 equals 8x minus 1. Pause your video. Solve it. Let me ask you a question. Once you found that x equals 1.5, did you plug it back in because you want to find the lengths of each side? If not, pause it. This side should be 14, this side should be 11, and this side should be 11. And again, if you don't know how to get that or any of these sides, ask your neighbor. All right, so this theorem up here means that if a line or segment bisects your vertex angle, bisects means cut in half, so you're going to take that top angle and you're going to cut it in half. We know it's in half because we're going to put congruency marks. Then it's also a perpendicular bisector of the opposite side. What that means is it's perpendicular and it bisects, which means it cuts the other side in half as well. So if your picture starts off looking like this, you can then draw your picture and make it look like this. So in PRS, triangle PRS, that means our edges have to be PR and S. Q is not on a vertex. So Q has to be my point down here in the middle. And S has to be my angle at the top. We can label this R or P. It doesn't matter, actually, but I'm going to label it like that. If it bisects it, it means it cuts it in half. So if it looks like this, then I know I can also draw this on my picture. We know SP is congruent to SR. We're going to draw a different number of tick marks on SP and SR. We know RQ is 4. P, if these two sides are congruent, then my angles are also congruent, so I'm going to mark them congruent. And P is 31. How many degrees does this little box mean? 90. So if we are looking for angle RQS, we're looking for this angle up here. Angle R has to be the same as angle P, so I'm going to label this as 31. And then this we know is 90. What do you know about all three angles in a triangle? They add up to 90. So I have x plus 31 plus 90 equals 180. Solve it. So you should get x equals 59. Sorry, I forgot to tell you to pause the video. Whoops, if you didn't, pause the video. Then we're looking for PR. PR is the whole way across. So if this side is 4, we know this side has to be 4, which means the whole way across is going to be 8. All right, let's look at the next one. We have triangle ABC. BD bisects ABC. So BD, D is my letter not in the triangle, so I'm going to put it here. The other side has to be B. It does not matter which one you choose to be A and C. If it bisects it, this cuts in half. We know this is a right angle. And so these are congruent. We know AB is congruent to CB. If those two sides are congruent, these angles are also congruent. So all of this you can get from here and forward. We know the measure of angle C is 71 degrees. We're looking for ABD, so we're looking for this right here. If C is 71, then A is going to be 71. We know this is 90. You're going to do the exact same thing you did up above. So 71 plus 90 plus X equals 180. Pause your video and solve it. All right, we're almost done. Equilateral triangles, they are also equiangular. That means all of their angles are going to always be the same measure. So if your picture looks like this, all three sides are congruent, then you can draw it like this and say all of your angles are congruent. If all of your angles are congruent, then you know that all of your sides are also congruent. Now, a cool thing to note, every angle, each angle, is always going to equal (60 degrees). So, right here, this triangle ABC, that's an equilateral triangle. So we're going to label all of our angles 60. And then if we look at CBD, that's this whole angle right here. This whole angle is going to be 130 degrees. We're looking for the measure of angle BAD. So this X right here. Notice this side is an isosceles triangle. So it's got those two tick marks, meaning that these are going to be congruent. So if that's X, this is also X. In order to solve for that, we have to know what this other angle here right here is. So we have to do 130 minus 60, and that gives us 70. And then we're going to look at it just with this triangle and say, well, all three angles in a triangle add to 180. So I have X plus 70 equals 180. So I have 2X plus 70 equals 180. Because I combined these. I'm going to subtract 70, and I have 2x equals 110. Divide both sides by 2, and you get x equals 55. And that's your answer. Oh, you couldn't see any of that. That's delightful. Here you go. All right, we're almost done. So this one, we know all of these angles are 60 degrees because these are all an equilateral triangle. This right here is a straight angle, so it's going to be 180 degrees. If we're looking for this angle right here, all we do is 180 minus 60, and we get 120 degrees. This one wants you to find angle NOP, so it wants us to find this. We know these two sides are congruent, so this is going to be the same as this. This is very much like what we did in example 1. You're going to take all three angles, add them up, and equal them to 180. Pause your video. You should get x equals 30. And then I'm leaving you example 3 to do on your own. Good luck.